Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. North and South versus East-West explains how directional traffic patterns influence the design, performance, and security of a network. Traffic flow refers to the path that data takes as it moves between devices, services, or systems. These flows can be categorized into two major types: north, south, and east-west. Each direction represents a different communication pattern and plays a distinct role in how networks are structured and managed. Understanding these patterns is essential for ensuring optimal routing, proper segmentation, and effective security controls across modern network environments. The Network Plus exam tests knowledge of traffic direction in both the design and operation domains. You may be required to identify whether a flow is north-south or east-west based on a scenario, determine how firewalls should be placed, or explain why a particular architecture is better suited for internal traffic. These concepts often appear in questions about segmentation, architecture, and troubleshooting. Being able to classify flows accurately helps you make sound design decisions and align network behavior with organizational requirements. North-south traffic refers to data movement that crosses a network boundary. This includes communication between internal users or devices and external resources such as internet services or remote networks. For example, when a user browses a website or a server sends data to a client over a wide area network, the traffic direction is north-south. It typically flows through edge devices like firewalls, routers, and proxies. Because it involves the boundary between trusted and untrusted zones, this traffic is highly scrutinized and tightly controlled. Security considerations for north-south traffic are well established. Firewalls placed at the perimeter of the network inspect both inbound and outbound flows, applying rules that block unwanted connections or filter suspicious content. Access control lists restrict which IP addresses or ports are allowed to enter or leave. Proxies may be used to inspect application-level data or provide additional visibility. This layered approach to perimeter security helps protect against threats like malware, data exfiltration, and unauthorized access, all of which are typically associated with north-south traffic. Examples of north-south traffic include common internet activities such as a user accessing a web application, a mobile device checking for software updates, or a corporate system sending telemetry data to a cloud service. These flows involve the crossing of a security boundary and require inspection for both content and behavior. On the exam, you may see scenarios involving user authentication, internet filtering, or DNS queries, all of which are north-south in nature. Recognizing this helps you apply the correct design and policy measures. East-west traffic, on the other hand, describes lateral movement within the same network or trust zone. This is the internal communication that occurs between devices such as servers, services, containers, or virtual machines. For example, when an application server talks to a database server or one container calls another microservice inside a cluster, that traffic is classified as east-west. Unlike north-south traffic, which passes through defined perimeter devices, east-west traffic often flows directly between systems inside the data center. East-west traffic introduces different security challenges. Because it happens within the network, it can be harder to monitor and control using traditional perimeter defenses. If a device becomes compromised by malware, the threat can spread laterally through east-west channels before it is detected. Internal segmentation is necessary to prevent this kind of lateral movement. Microsegmentation, which applies granular access controls within the internal network, is one of the most effective strategies for securing east-west flows. Detecting and monitoring east-west traffic requires visibility inside the network. This can be achieved through the use of host-based agents, internal firewalls, and flow monitoring systems. These tools track which systems are communicating, how often, and over what protocols. Telemetry data and traffic logs help identify abnormal patterns that might indicate lateral movement or unauthorized access. Ensuring east-west visibility is crucial for compliance, threat detection, and internal performance optimization. Traffic flow direction also affects how a network is designed. Networks that anticipate large volumes of east-west traffic such as virtualization clusters or CloudNet platforms, need to be built with low latency, high bandwidth links between internal systems. Aggregation layers and switching fabrics must support symmetrical traffic paths to avoid bottlenecks. In contrast, networks with heavy north-south traffic, like branch offices or perimeter-facing applications, require strong perimeter routing, filtering, and load balancing to manage traffic moving in and out of the network. VLANs are commonly used to manage east-west traffic. They provide segmentation at layer 2, isolating groups of devices into separate broadcast domains. East-west communication between devices in the same VLAN flows freely, but traffic between VLANs must pass through a router or layer 3 switch. Trunk ports carry inter-VLAN traffic across links between switches, and these trunks must be configured to allow only the necessary VLANs. Policy enforcement at the router or switch ensures that only approved east-west traffic crosses VLAN boundaries. In the context of data centers, east-west traffic has become dominant. Virtual machines, container workloads, and microservices often communicate heavily within the infrastructure. These frequent internal exchanges generate far more traffic than client-to-server interactions at the perimeter. Spine and leaf architectures are specifically designed to support this pattern, providing equal cost paths and consistent latency between any two endpoints. Overlaid networks further enhance flexibility by enabling dynamic segmentation and virtual connectivity across physical boundaries. For more cyber content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Microsegmentation is one of the most effective techniques for controlling east-west traffic and improving internal network security. It involves creating highly granular policies that govern how individual devices or groups of devices can communicate. Rather than relying solely on perimeter defenses, microsegmentation enforces access control within the data center or enterprise network. This is typically achieved using software firewalls, virtual tags, or access policies managed by a controller. By applying security at the level of each workload or device, microsegmentation significantly reduces the risk of lateral movement by unauthorized users or malware. Firewalls play a vital role in both north-south and east-west traffic control. Perimeter firewalls handle the inspection and filtering of north-south traffic, blocking unauthorized access to internal systems and monitoring outbound connections to the internet. Internal firewalls, whether physical or virtual, inspect east-west traffic within the trusted network. This layered approach ensures that even if an attacker breaches the perimeter, internal controls remain in place to detect and contain threats. On the exam, you may be asked to identify which type of firewall or placement is appropriate for a given traffic flow. Bandwidth characteristics differ between north-south and east-west traffic, and understanding these differences helps in proper capacity planning. North-south traffic often relies on wide-area network links, which are typically slower and more expensive than local connections. Bandwidth in this direction may be limited by internet service providers' speeds or external bottlenecks. East-west traffic, in contrast, occurs on local area network or data center fabric links, which are much faster and have higher capacity. As a result, networks with heavy internal communication require robust switching infrastructure and low-latency connections to avoid performance degradation. Application placement strategies should take traffic flow direction into account. Services that frequently communicate with each other should be co-located within the same VLAN, subnet, or availability zone to minimize east-west latency. Gateways, proxies, and external-facing interfaces should be placed at the network edge to filter north-south traffic before it enters sensitive zones. Aligning the physical and logical layout of applications with their traffic patterns reduces unnecessary hops, improves performance, and simplifies policy enforcement. The exam may test your ability to choose optimal application placement based on flow analysis. Troubleshooting traffic issues often begins by identifying whether the affected traffic is north-south or east-west. Flow records, packet captures, and logs provide insight into the direction, source, and destination of data. Directional analysis helps pinpoint whether the issue lies in perimeter routing, internal switching, firewall rules, or overloaded links. Bottlenecks can occur anywhere along the path, but knowing the flow type narrows the scope of investigation. For example, if users report slow access to external websites, the issue likely involves north-south traffic. If internal applications are failing to communicate, the focus shifts to east-west analysis. Policy enforcement should reflect the nature of the traffic it governs. Access control lists applied at the perimeter are typically strict, allowing only known traffic patterns to pass. Internal ACLs may be more flexible, but they still require careful planning to prevent privilege escalation or unauthorized communication. Critical services such as authentication servers, databases, or management consoles should have tightly restricted access from all directions. Traffic shaping policies may also vary by flow type, with bandwidth limits or prioritization rules designed to match business needs. Knowing how to apply these policies effectively is a key skill tested on the exam. Monitoring tools provide visibility into both north-south and east-west traffic patterns. Protocols like NetFlow, SFlow, and IPFIX capture metadata about each flow, including source, destination, protocol, and volume. These tools generate reports that reveal which applications consume the most bandwidth, which devices communicate most frequently, and where anomalies occur. Flow visibility is essential for capacity planning, security auditing, and troubleshooting. Effective monitoring helps validate policy effectiveness, detect unauthorized behavior, and guide network optimization efforts across all traffic directions. The Network Plus exam includes several topics related to traffic flow that test your ability to distinguish between north-south and east-west behavior. You may be asked to classify examples of each, identify appropriate security controls, or recommend design changes based on flow direction. Understanding these concepts supports broader topics such as network segmentation, VLAN planning, firewall deployment, and performance analysis. A strong grasp of traffic flow direction is essential for answering both straightforward and scenario-based questions with accuracy. Network traffic flow is a fundamental concept that affects nearly every aspect of design, performance, and security. North-south traffic moves between trusted networks and external systems, while east-west traffic stays internal, flowing between local devices and services. Each direction presents unique challenges and requires specific infrastructure, policy, and monitoring strategies. Recognizing and planning for these patterns ensures that networks remain secure, responsive, and aligned with application needs, both in exam scenarios and in real-world implementations. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.